Hey there, tech enthusiasts! Today we're going to explore the amazing world of computer networks. Picture a huge web of devices all chatting with each other. That's basically what the internet is. To understand how this giant communication system works, we need to learn about the Open Systems Interconnection Model, or OSI model. Think of the OSI model like a yummy layer cake. Each layer is a step in the process of sending and receiving data over a network. Just like each cake layer has its own ingredients and job, each OSI layer has specific tasks to make sure communication is smooth and reliable. From the physical cables and signals to the apps we use every day, the OSI model helps us break down this complex process into easy-to-understand parts. Today we'll zoom in on one important layer, the data link layer. Get ready for a fun journey into the heart of network communication. Let's dive into the second layer of our network cake, the data link layer. This layer is like the traffic cop for data, making sure it moves smoothly between devices that are directly connected, like two computers sharing the same network cable. Think of it like sending a postcard to a friend. You wouldn't just scribble their name on a blank piece of paper and hope it gets there, right? You'd write their full address, including the street name, city, and zip code, to make sure it reaches the right place. The data link layer is like the postal service for your data packets, ensuring they get to the right device on your local network. It provides an addressing system for devices on the same network, allowing them to find and talk to each other easily. Before we send our data on its journey, we need to pack it up nicely. This is where data encapsulation comes in. Imagine putting a letter inside an envelope before mailing it. The envelope keeps the letter safe and adds important delivery details. Similarly, the data link layer wraps data packets from the network layer into frames. These frames are like envelopes for our data, adding a header and a trailer with key info for delivery and error checking. The header includes the sender's and receiver's MAC addresses, which are unique IDs for devices on the network, just like a return address and recipient address on an envelope. The trailer usually has a special code called a checksum, which helps find errors during transmission. Section 4. Framing the message structure of a data frame. Let's dive into the structure of a data frame. Imagine sending a postcard. The frame is like the postcard with specific spots for different information. Just like a postcard has places for the address, stamp, and message, a data frame has fields for various purposes. The header, at the start of the frame, has the source and destination MAC addresses, making sure the data gets to the right place. Think of these addresses like the to and from fields on an envelope. The payload or data section holds the actual information being sent, like the message on your postcard. This could be anything from an email you're sending to a video you're streaming online. Finally, the trailer at the end of the frame usually has the checksum for error detection. This makes sure the data hasn't been messed up during transmission, like a quality check before the postcard is delivered. Chapter 5. Oops, wrong address. Let's talk about MAC addresses and why they matter. Remember those MAC addresses we mentioned earlier? Think of them like unique fingerprints for every device with a network card, like your computer or smartphone. Each device on a network has its own special MAC address, making sure data packets get to the right place. Imagine this, you're throwing a party and inviting all your friends. Each friend has a unique name, right? You wouldn't just shout, "Hey you," and hope the right person responds. You'd call them by their name. MAC addresses work the same way, helping devices on a network recognize and talk to each other without mix-ups. When you send data over a network, the data link layer uses MAC addresses to make sure it gets to the right device.